It's April 2013, and an amateur radio astronomer in the UK is scanning a frequency band that hasn't carried a legitimate signal in decades. He's not expecting anything. This band, 237 megahertz, was assigned to a single satellite launched by the US Air Force in 1965, declared dead in 1967, and never spoken to again. Then his receiver picks something up, a pulse. Then another. Regular rhythmic, mechanical, nothing like background noise, nothing like interference. Whatever is transmitting on this frequency is spinning, and it's alive. The satellite's name is LES-1, Lincoln Experimental Satellite 1. It has been floating in orbit, silent, for 46 years, and somehow, it just started talking again. To understand how a piece of Cold War hardware could wake up nearly half a century after everyone gave up on it, we need to go back to why it was built in the first place, and how something built to last only a few years ended up outliving the people who designed it. In the early 1960s, the U.S. military had a communications problem. Radio signals bounced off the ionosphere could only travel so far, and they were unreliable, easily disrupted by weather and solar activity. Satellites promised something better, a relay station in space that could bounce a signal clean across the globe. But nobody had figured out how to do this cheaply, reliably, or at a useful frequency band yet. MIT's Lincoln Laboratory took on the challenge. Their job was to build a series of experimental satellites, cheap enough to fail without disaster, to test out ideas that bigger, more expensive military communication systems would later depend on. LES-1 was the first of this line. It was small, roughly the size of a beach ball, spin-stabilized rather than actively controlled, and powered by silicon solar cells wired directly to onboard batteries. Nothing fancy. Nothing redundant. It was built to answer one question: can a satellite reliably relay a signal at ultra-high frequency? Nothing more. On February 11, 1965, LES-1 launched aboard a Titan rocket from Cape Canaveral, and almost immediately, something went wrong. The rocket's upper stage failed to fire correctly. Instead of reaching its intended circular orbit, LES-1 was stranded in a lopsided elliptical path, tumbling instead of spinning cleanly, and unable to complete the very mission it was built for. Engineers at Lincoln Lab did what they could. They ran tests, gathered what data they were able to, and confirmed the basic communications hardware worked, even if the satellite itself never got to do its intended job properly. By 1967, LES-1 had gone quiet. Its batteries, never designed to last more than a few years, had likely degraded past the point of being useful. Ground teams stopped listening. There was no reason to keep tracking a dead experiment. LES-1 was logged in the catalog of orbital objects, marked as defunct and forgotten. For engineers, defunct doesn't mean destroyed. It just means nobody expects to hear from it again. For 46 years, that assumption held, which is what makes the 2013 detection so strange. When the pulses were first picked up, the immediate assumption wasn't that a 50-year-old satellite was somehow transmitting. It was that someone had made a mistake. Maybe the frequency was misidentified. Maybe it was a different object entirely. Something more recent whose orbital data had simply been logged incorrectly. So the amateur astronomer who first caught the signal did what any careful investigator would do. He didn't announce a discovery. He tried to break his own result. He cross-referenced the pulse rate against known objects in that orbital region. He checked timing against the object's predicted pass overhead. If this was really LES-1, the pulses should sync up with the satellite's known tumble rate, and they should appear and disappear exactly when the object rose and set from his location. They did, every time. Other amateur trackers around the world picked up the same signal independently at the predicted times on the predicted frequency. Multiple independent observers using different equipment in different countries were all seeing the same result. Something at LES-1's cataloged orbital position was transmitting a rhythmic pulse, on the exact frequency LES-1 was designed to use. The signal wasn't a fluke, and it wasn't new hardware. All the evidence pointed to one explanation nobody wanted to say out loud at first. LES-1 itself, silent since 1967, was still alive. But how? A battery that stopped working in 1967 doesn't spontaneously start working 46 years later. So, if LES-1 was transmitting, something else had to be powering it. The answer comes down to how the satellite was actually built, and what happens when a spacecraft loses its brain but keeps its body. LES-1's power system was about as simple as spacecraft electronics get. Solar cells covered its exterior, wired to batteries that stored charge and fed the transmitter. In a healthy, functioning satellite, this system is regulated. Circuitry manages how power flows when the transmitter fires, how the satellite responds to commands from the ground. That's the intelligence layer. That's what makes a satellite, instead of just a spinning hunk of metal with solar cells stuck to it. The leading explanation for LES-1's revival is that, over the decades, this intelligence layer failed. The battery cells almost certainly degraded to the point of being unable to hold a meaningful charge, or possibly failed outright, shorting internally. But the solar cells themselves, simple silicon photovoltaic panels with no moving parts and nothing to wear out chemically, kept doing exactly what they were built to do: convert sunlight into electricity. With the regulating circuitry gone or badly degraded, that raw electrical current had nowhere controlled to go. Instead, it's believed to be feeding almost directly into the transmitter whenever the solar panels face the sun. No battery buffering it, no control system managing it, just raw current flowing straight from panel to transmitter every time sunlight hits. And here's where the satellites tumble. The very flaw that doomed its original mission becomes the reason it's still detectable today. Because LES-1 was stranded in an uncontrolled tumble instead of a clean spin, its solar panels sweep in and out of sunlight as the satellite rotates. Each time a panel catches the sun, it generates a burst of current. That burst hits the transmitter. The transmitter fires a pulse. Then the panel rotates out of sunlight. The current stops and the pulse ends. Rotate back into the sun, and it happens again. That's the rhythmic pulsing the amateur astronomers detected. It isn't a message. It isn't a system reporting telemetry. It's closer to a broken doorbell, wired straight to a solar cell, ringing every single time the sun happens to hit it, with no one on the other side of the door and no memory of ever ringing before. In a strange way, LES-1's failure and its resurrection are the same story told twice. The rocket stage failure that stranded it in a tumbling orbit ruined its intended mission in 1965. But that same tumble is precisely what makes its accidental signal readable today, sweeping its solar panels in and out of sunlight on a predictable rhythm that trackers on the ground could isolate and confirm. Once the identification was solid, the story reached professional space trackers and eventually the wider astronomy community. There was no ambiguity left. LES-1, cataloged as defunct since the 1960s, was transmitting a signal caused entirely by sunlight hitting exposed solar cells and flowing, unregulated, into a decades-old radio transmitter. Nobody on the ground was controlling it. Nobody had sent it a command. It wasn't really awake in any meaningful sense. It was simply still capable of doing the one small physical thing its hardware had never lost the ability to do: turn light into a pulse of electricity and push that pulse out as a radio signal. LES-1 isn't unique in this. It's one of a growing number of zombie satellites, spacecraft that are officially dead, no longer controllable, but still physically capable of producing some kind of detectable signal or motion. Amateur trackers have found other decades-old satellites still tumbling in predictable, cataloged orbits, some still faintly transmitting, most simply drifting as inert metal. Space is an unusually forgiving environment for a piece of hardware to just sit in. There's no weather to corrode it, No gravity pulling it down quickly, no other objects around to knock into it very often. A satellite that stops working doesn't disappear. It just keeps orbiting exactly where physics put it for decades or longer, waiting for nobody in particular. That permanence is also becoming a problem. Every dead satellite, every spent rocket stage, every fragment from a past collision stays in orbit indefinitely unless it's deliberately deorbited or happens to be low enough for atmospheric drag to eventually pull it down. Low Earth orbit alone now contains tens of thousands of tracked objects, the vast majority of them defunct. LES-1 still up there, still tumbling, still occasionally pulsing out a signal to nobody, is a small reminder of just how much of our own history is still quietly circling above us, decade after decade, waiting. Which is, in its own way, what makes this story land the way it does. LES-1 was never supposed to matter after 1967. Its engineers moved on to later, better designs. Its mission was a partial failure from the very first day it reached orbit. By any reasonable measure, it should be a footnote, a paragraph in an old technical report nobody reads anymore. Instead, 46 years later, someone pointed an antenna at the sky and heard it ping. Not because anyone built it to last that long, not because anyone remembered it was up there, but because a handful of pieces of 1960s era silicon doing the one simple job they were built to do never actually stopped working. Nobody was listening. Then one day, somebody was. And the ghost had never actually left the room. It had just been talking to an empty sky the entire time.